This time, we will go back to everyone's favorite theme. That is, we would like to address the subject of black holes, their characteristics, and the topic in general. Hello guys! After all, do black holes really exist? Do they have a more complex structure than can be expressed in simple terms of conventional physics? Let's answer these fundamental questions about black holes. Well guys, welcome to our channel. So it's time for us to start our content. What is a black hole? In the classic image of scientists, a black hole is a celestial object with an extremely strong gravity where nothing can escape. This celestial object arises when the nucleus of a massive supernova collapses, concentrating all its mass at a point called singularity. The larger the mass, the greater the event horizon formed around the black hole. In modern astronomy, there is no doubt that black holes exist. However, despite this, there are many paradoxes associated with black holes. For example, if a black hole does not emit anything and does not have entropy in general, this contradicts the second law of thermodynamics. Fortunately, this paradox was solved by Dr. Hawking, and now we know that black holes really emit energy, which means that they lose mass very slowly over time. However, there are still other paradoxes. One of the most notable is known as the paradox of information in black holes. When a black hole absorbs something, it first disintegrates almost everything into elementary particles before absorbing it. In this process, the characteristics of the black hole remain practically unchanged, with only a slight increase in mass. Currently, thanks to Dr. Hawking, we know that black holes do not exist forever, but instead they evaporate, eventually returning to their previous state of absorption. However, the waves radiated by the black hole have nothing to do with the matter that was absorbed. As a result, the information about what fell into a black hole is irreparably lost. In addition, except for the mass, the characteristics of the black hole remain practically unchanged. However, gravitational fields do not transmit information. In this way, the complete loss of information goes directly into contradiction with the quantum theory of fields. There are many other problems and paradoxes associated with black holes. In addition, even when a problem seems to be solved, new problems arise quickly. In short, as mentioned above, there is no doubt that black holes are real. Recently, images have confirmed the existence of black holes, dispelling any doubt. Despite this, the understanding of the true nature of black holes is still far from being achieved. However, fortunately, there is a field in modern physics that is the most extraordinary and mysterious that offers us help. This is the theory of strings. Black holes, strings, and new terms. When studying the mechanics of the interactions of elementary particles with the theory of strings, elementary particles are not treated as punctual particles. In this theory, elementary particles are considered as one-dimensional objects with fixed length and tension, that is, they are treated as string vibrations. Through the vibration of these strings, a variety of elementary particles and their fundamental forces are generated. Some physicists hope that if a definitive confirmation of the theory of strings is obtained, it may enter the Hall of Fame of theories. Scientists have been looking for almost 100 years for this holy grail that would unite all the fundamental forces. The main one among them was Einstein, who spent decades trying to deduce it. The theory of strings still lacks solid evidence and, for now, remains an empty type of theory. However, it offers answers to our questions about black holes. In short, in the perspective of the theory of strings, a black hole is considered a ball of hair, which is a structure composed of a string closed with high tension and special objects of lower dimension called strings. Some of these strings can move between the strings, while others are directly linked to them. These structures are called fuzzballs. Explaining what a fuzzball is extremely difficult, despite all the discussions related to the theory of strings being like this. However, if you are interested, I would like to try to explain it here. Well, a fuzzball is a complex structure composed of many strings and strings arranged intricately, being able to assume several different configurations. Each fuzzball has finite parameters of size and density. This means that inside a black hole, below the event horizon, there is no singularity but a fuzzball. This does not affect the external characteristics of the black hole in any way. Despite this, black holes still seem to have a spherical event horizon, bending the light and swallowing everything that falls beyond the event horizon. However, when considering the black hole as a fuzzball, many of the mysteries surrounding this peculiar celestial object can be solved. First, the information paradox mentioned earlier here in our video is an example of this. When considering the black hole as a fuzzball, this problem is solved. Within these black holes, the information that falls along with the radiation and the absorbed matter not only increases the mass, but also modifies the state of the fuzzball. In this way, all the information absorbed is recorded and can be read when the black hole eventually disintegrates. In addition, in the theory of strings, since the area and the volume of the fuzzball are equal to each other, this also solves other paradoxes. Specifically, the contradictions related to the entropy of a black hole and its area are eliminated. According to some calculations, the entropy of a black hole is directly related to its surface area, but from the point of view of quantum physics, the entropy should be related to the volume and not to the surface area. Due to the reasons mentioned above, there is no longer any contradiction. However, leaving aside the question of evidence, there is still a question to be considered. In traditional models, there is a clear image of how black holes are formed. As mentioned above, they are originated when the nucleus collapses, imploding inward, causing an extreme contraction of all matter. The question of how a fuzzball arises during the collapse is, in fact, a great challenge. Naturally, it can be considered that at the moment the explosion occurs and the collapse inside a star, everything, including the laws of physics, becomes highly chaotic. This is probably partially true, and the Abrahamian strings may in fact be confused. Or maybe in reality, only some black holes that originated at the beginning of the universe are fuzzballs, while the others that formed from explosions do not have this characteristic and have conventional singularities. However, in the second case, the problems related to the black holes mentioned above may resurface. Foreseen evolution. As mentioned here in our video, the biggest problem with the string theory is the complete lack of evidence that it is correct. So far, it has not been possible to detect strings or fuzzballs. In addition, scientists who study strings often report that they are lost in a maze of infinite calculations, hypotheses, and contradictory data. Although quantum physics as a whole also faces similar problems, at least its validity has been confirmed, becoming virtually indispensable in many fields of science. On the other hand, the string theory still remains in an uncomfortable position. In the case of the fuzzball, we come across the situation in which we cannot easily spy beyond the event horizon of the black hole. Even if there were indestructible space probes or capsules made of material capable of resisting the extreme force of the tide of a black hole, and that could come down from the other side of the event horizon, they would not be able to transmit information. This is because the information cannot travel faster than the speed of light. Well, folks, and with that, we end our video today. To all of us, thank you very much for watching. I hope you enjoyed this video. Even if you maintain a skeptical position, the interpretation of black holes in the string theory leaves nothing to be desired in relation to conventional quantum physics. And that is undeniable. Perhaps in the future, deeper investigations into strings and strings will lead to the understanding of their true nature, and the fuzzball theory may play a crucial role in understanding black holes. One day, perhaps, we will reach a level of technology in which we can create low-mass black holes on our own. Since the useful life of these black holes will be short, we will have the opportunity to observe the entire process from its creation to its extinction. If we can allow these black holes to absorb radiation and matter, inevitably causing explosions, and then recover information about the feeding of strings and strings of their backups, we can obtain solid evidence for this theory. And if you liked this video and want the theme of space to gain more prominence with more information about it, please leave a like and share on your social networks. And now it's time for us to say goodbye here. A big hug, and until our next content here on Wikivedia Plus channel. Bye.